Well, hello. This is this week's project. I have another switch mode power supply. This is an EVGA. Apparently this is pronounced EVGA, not EVGA as I was pronouncing it for the last one, but you live and learn, as they say. I know you guys have got my back on this, all right? So it's those sort of things I need advice on. So it's EVGA B5 series power supply, and it is, I think that's 650 for 650 watt. I don't have the modular connections with this one, so what I did was I plugged it in and I just checked for standby voltage on this, which is the 24 pin connection here. There's no standby voltage, there's no nothing. It's just simply doing nothing. So I'm gonna have to take the board out of it, and we'll run through the same procedure again just to see if we're getting power, if the fuse is blown, and I'll bring you through each step, so don't worry about it. So come with me for the spin and we'll see if we can get this sorted.
I've taken out the power board, and this is the image of it right here. It came out quite well. It's a little bit dark. The power supplies come out a little bit dark, but it's certainly something that we can work with. But at this point I must put in the usual disclaimer. Working with high voltage electronics is extremely dangerous. This video is for demonstration purposes only. Please do not follow what I'm doing here. Just to note, before doing any work on this board, I found the two large main filter capacitors, which on this board are located here and here. I discharged the two of them to make sure that there was no residual voltage on the board and that it was safe to work on. So after I discharged those, I then went looking for where our AC comes onto the board. Now this is usually easy to spot because it's the wire from the mains. So where I found these was down here. This is where our live wire comes in, which is a brown wire, and this is where our blue wire comes in. That's the neutral wire. And I can see straight away here, these 4 pins in a row are most likely our bridge rectifier as well. So I'm going to start my testing at the input section here. I'm going to test and make sure that there is a continuous path from our live wire to the center pin of the bridge rectifier, and from our neutral pin to the other center pin of the bridge rectifier. So with the power plugged out and my main filter capacitors fully discharged, I introduce my multimeter in continuity mode, which looks like this in my multimeter. And then I want to check for continuity between where the live wire comes into the board, which is here, and the center pin of the bridge rectifier, which is right here. And I find that there is continuity here. There's only a small input section on this board, as you can see. There's literally just, I think there's an MOV across here for safety, and then it's just one inductor. So the path from here across that inductor is continuous, and we're going to mark that in now. Next, in continuity mode, once again, we check the neutral wire. So this is where the neutral wire comes in, so I place my probe here and place my black probe to the other center pin of the bridge rectifier, and it beeps, so we also have continuity on the second wire connecting to the bridge rectifier. So let's mark that in. Some of you may have noticed that there is a piece of touch-up solder on this here, and there is a break in the track over at this point here. Now, these were two issues that were caused by me not taking enough care taking the board out of the chassis, which was quite difficult to do. Now, I've resolved both of those issues. I took out both inductors and tested and checked the tracks. I actually resoldered this after I took the picture. So just to point out that these are nothing to do with the original fault. They were caused by me taking the board out of the chassis, and I'm confident that I've resolved both issues. So we've confirmed this small input AC input section here is good up to the bridge rectifier. We have continuity from our live wire to the center pin here, and continuity from our neutral wire to the other center pin. So we need to know, is the bridge rectifier doing its job of rectifying that 230 AC to approximately somewhere between 310 and 320 DC. So let me mark out the pins of our bridge rectifier here. So this is our DC ground, this is our DC positive, and these are 2 AC pins where the input comes in here. So we need to measure the diodes in the bridge rectifier package to see if they are all okay, and that's what we're going to do next. So I introduce my multimeter in diode mode, which looks like this on my multimeter, and then once again with the power switched off and the main filter capacitor discharged, I take the measurements of the diodes in our bridge rectifier. So to measure the first diode, I place my black probe to V positive and my red probe to the first AC pin, and I measure 0.530, so the first diode is good. I then move my red pin onto the second AC pin, and I also measure 0.530, so the second diode is good. Now, to measure the other two diodes, I place my red probe to the ground and place my black probe to the AC pin here, and I measure 0.530. So the third diode is good. And then when I place my black probe to the other AC pin, I also measure 0.530. So what that tells me is the 4 diodes in my bridge rectifier are all measuring correctly. So it looks like there is no issue with the bridge rectifier. Okay, at this stage we have confirmed that our AC input section is good up to the 2 center pins of our bridge rectifier, and we've also confirmed that the 4 diodes in our bridge rectifier package are good. So the next step is to confirm that there is connectivity between our ground pin and our positive pin on the bridge rectifier, which carries the high voltage DC, and our main filter capacitor, which is this capacitor right here. So we're going to do that now. Okay, so I traced the path from our V positive to the positive pin of our main filter capacitor, and it goes like this. So it comes from here, across this path here, up here. There's actually a diode at this point, so it jumps across here. And then there is a thermistor. You may remember this is the component that blew in the last EVGA power supply that we looked at. But across that thermistor there and onto the positive pin. So let's mark that out on the circuit board now. Next, I'm going to trace the path from the ground pin of my bridge rectifier to the ground pin of the main filter capacitor right here. Okay, so having traced the 2 paths, we now need to verify that there's connectivity. So what I'm going to do here is I'm going to switch the multimeter into diode mode. Once again, the power is still off and we're in diode mode. So I place my red probe to the positive pin of the bridge rectifier, and I place my black probe to the positive pin of the main filter capacitor, and when I do that I measure 0.504. Now you're thinking, why is that measuring diode? Why am I measuring in diode mode to start with, not continuity? Well, sometimes they actually have a diode between the positive pin of the bridge rectifier and the main filter capacitor, so that's what I'm measuring across here. It's also measuring the fact that the thermistor is good on this one, otherwise it would be no connection at all. So when I measure 0.504 on that, that is essentially telling me that there is continuity between V positive across that diode, across that thermistor, and to the positive pin of our main filter capacitor. Similarly, we then need to measure from the ground pin here to the ground pin of our main filter capacitor. We've got them all crossing over here. But when I place my probe here and measure the ground, there is continuity along this path also. So what does that tell me? Well, that tells me when I convert the AC to 230 AC to 310 to 320 DC, that should be making it onto our main filter capacitor here. So what I'm going to do next is, there's no more tests really that we can do with the power off. As I said before, I like to measure with the power off because it's just safer. So what we need to do next is measure with the power on and see if we are actually getting our 310 to 320 volts DC across this main filter capacitor right here. I've plugged in the power supply and I introduce my multimeter in the 1000 volt DC range. I place my black probe to the negative pin of our main filter capacitor and my red probe to the positive pin of the filter capacitor. I find that there's 308 volts across this. So that looks good to me. So I think we're happy enough at this stage then that our whole AC input stage is good up to the bridge rectifier. Our bridge rectifier is working, and the path then from the bridge rectifier to our main filter capacitor is also good. And we're measuring an appropriate voltage across our main filter capacitor. So where to next? This is the view of that same board from above. This is our main filter capacitor, which we have 308 volts on, so that looks okay. The next question is, where is our standby circuit, and check and see why is there no 5 volts on that. Well, how do we identify where our standby circuit is? Well, a standby circuit has its own transformer on these ATX power supplies. So we usually have 3 transformers on these. So we've 1, we've 2, and then we've 3. So the 2 of these are associated with the main power rails, and they're usually only involved when it's fully powered on. This one here is the standby transformer. So I'm going to have a look at the section around here and see if there's any difficulty with this. There's a small IC here which is a TNY 290 PG, I think. That drives the transformer, and the 5 volts is then rectified on the other side, but it's not available. So I'm going to take a look at this from the underside, and we'll take it from there. Back on the underside of the board again, this is where our transformer is. This is our standby transformer right here. Down here is where you can see our chip. This is the TNY 290 PG that drives the transformer, and you can see that there's a diode here that rectifies the AC in the transformer, and that produces our 5 volts. So what usually happens in this situation, we have our 308 volts DC across this filter capacitor. That's usually broken down using resistors to give you an input voltage to this IC. So we need to verify that we are getting power to this IC right here. That would be the first step. Okay, so with our 308 volts at this point here, we can see on that same track, if we follow it across, there's a jumper here, there's a resistor, a large value resistor, another large value resistor, and this is actually connected to this pin right here, which is the enabled pin of the TNY 290 PG. So what I'm going to do is, with the power off and the capacitor discharged, I'm just going to verify that all of these are the proper values, and then we're going to measure the voltage here. Okay, so I've marked out the path, and again with the power off I decided I would measure every resistor in the path. So I measured this as 2.2 ohms, which corresponded to the lines on the resistor, because that's a through hole resistor. These SMD resistors, they measure the proper value, 2.0 mega ohms and 2.2 mega ohms, and that then is connected, it jumpers across here, but it's also connected to the enable pin of our IC. So everything in that path seemed fine. So what I did was I powered it on and I measured the voltage at this point, and it measured as 1 volt, very, very stable. So we've confirmed that the IC that drives the standby transformer is getting 1 volt on its enabled pin, which I think is correct. So the question is then, are we getting the correct voltages on the drain and the source pins here? So I'm marking out those now. So that's the drain pin, and the source pin is actually the 4 pins over on this side. So when I had it switched on and measured the voltage across these, I measured 308 volts across the drain and source. Now remember, I wasn't measuring standby voltage at the start of this video, so I'm curious to see what exactly is not working here. So with the power off, once again, I measured this diode and tested it, and I measured this capacitor and tested it, and both tested fine. So I don't actually have an oscilloscope to check for, the AC signal being generated and sent to the transformer. So the best I can do is just jump across. I checked this diode, which rectifies the 5 volt, and that tested fine as well. And then just as one last test, I just said, look, just let me check and see what voltage is on this capacitor. This is the output capacitor for the 5 volt standby. And obviously with the power on, I measured across the capacitor and I found 5.1 volts here. So the standby voltage is actually working on this. This is the connection from the back of the power supply again. You see, what I'd assumed was that this was the 24 pin connection, so I was looking for the standby voltage on the regular 24 pin connection, but if I'd only counted, there's obviously 28 pins in this, so it doesn't correspond. But when I had established that there was 5 volts on that capacitor, I came back out here and more carefully measured, and I found 5 volts on this pin here and on this pin here. So I think that this is the standby voltage, and I think this pin here is the one that switches it on and off. Unfortunately, I've run out of time this week, guys, so I'm going to have to leave the video there. So what have we done this week? Well, we've established the input section of this switch mode power supply. We've worked out that the bridge rectifier is working and we have an appropriate voltage across the main filter capacitor. And then I've pushed it a little further into starting about troubleshooting the standby circuit. Again, my idea with these videos is to try and have, you know, a one-stop shop where we can go through a switch mode power supply, the step-by-step on how to repair. I'm still not sure that it's going to be feasible at this stage, but I'm going to keep trying at the moment. I don't have any laptops in. I know that's what all you guys are interested in. So in lieu of doing nothing this week, this is what I got for you. I have 3 graphics cards that I bought, and I'm going to be working on those over the Christmas, so keep tuned. I will work away on this power supply in the background, and I will post a follow-up when I make more progress with it. So thanks for watching. Keep posting comments down below. Let me know what you think of what I'm doing. All comments are appreciated, both good and bad. So please post whatever you want to say down below, and I'll take a read of it. And I'll catch up with you guys next week.